like an hour, you know. Okay, so who wants to give me one simple machine they saw in there? An example. I know there's way more people who saw them in there. Yeah. Yeah.
Like example of like what happened?
Just any one simple machine in there that you saw.
Well,
or what happened, either way.
The cannons when the ball hit it and it shot.
Okay. Cool, the cannons, good. Another one? I saw your hand before.
I forget which one it's called, but it's like there's weight on one end and then like it'll swing.
Alright, so who can think of the name? If you have weight on one end, the other swings it up.
Campbell.
Lever, yeah, so that's a lever. Yes, what's another one?
Would be a tug and pull when like the string is like wrapped around and pulled over and over. That would be a tug and pull.
So that would have been a tug and pull. What's another word for a tug and pull? What's something where you have a string and then it pulls it down? Pulley. Yeah, exactly. Perfect. No, I know that's what you meant. Good. All right. A pendulum. Where did you see a pendulum? You know, when the hammer smashed the TV? Yeah, so what is a pendulum? And we had our six, so we had a screw, an inclined plane, a pulley, we had a lever, and what? What's another one? A blanket, yeah? Wheel and axle, good. Where was the wheel and axle that we saw?
When you like push the car backwards.
Yeah, the car, exactly. All right, let's hear one more. Yeah.
Wedge.
A wedge. Where did you see a wedge? Oh, and that was the last one. Thank you. Did you see any in there? No. So a wedge is like, it's kind of hard because a wedge is pretty much just two inclined planes together if you think about it. So I don't know if they had any wedges in there, and that would have been hard to see because I was moving so fast. There's one thing I want to point out. You know yesterday in that Bill Nye video how they took two levers that were bent and they turned them into a wheel? So a lever is just like a part of a wheel. There's also, you guys remember that bowling ball, how it was rolling in a circle? And that was an inclined plane. But what does that also kind of look like? What's another one? A screw, yeah. So a screw is also kind of just like a mini inclined plane that goes in circles. So a lot of these simple machines are kind of like built off one another, and they're pretty similar. Ideal mechanical advantage is, well, does anyone have like any idea what the ideal kind of means? Like in general, it doesn't have to be within science.
Best.
Best?
Like perfect.
Perfect. Okay, good. So, do we live in a world where everything mechanically works perfectly?
No.
No, sadly we don't. So, ideal mechanical advantage is going to be our advantage in a perfect world. So, it's kind of like if you were to guess, if you were to put in all the work, get exactly all of that work out, and have everything worked perfectly, that's how we calculate our ideal mechanical advantage. Most of the time we can't get everything out of what we put in, like if you put in a little energy, some is going to be lost to, like, say, sound or heat. And so this is kind of not taking that into account.
That's like 2 points.
How did you calculate that? Yes, yeah, so what we have, the weight of these washers is 100 grams.
Yeah, so it was 200, which was around. Oh, for each one it's 1 Newton.
Yeah, so 100 grams is equal to 1 Newton. You can see that on here. If you look at it, like 1 Newton, 100 grams, 2 Newton, 200 grams. And so your resistance, does the weight of this ever change? No. So you had to push in different amounts for the length, but this never changed. So your resistance force is going to be the exact same for all three parts.
Oh.
And then what numbers are you going to use for your episodes? Yeah.
Oh,
and so you don't have to do one for each child. That's why you use your average. So just use your one resistance force. My last slide with your average force. So bad.
You can't record us.
I know.
Yes.
That's fine, sorry.
What you guys